This video is over lesson 103, dividing radical expressions. So ladies and gentlemen, the quotient property of radicals is basically the distributive property applied to radicals over division. So if we have a radical where it has an index, does not have to be a square root though, so it could be any root, and we have a division problem inside, so we have a fraction. Basically, the root or the radical will distribute to both the numerator and the denominator. Now, of course, we cannot have 0 in denominators, so b can't be 0. So ladies and gentlemen, this leads us to a concept that you will be using a lot as you move forward in your mathematical education, where we don't allow radicals to be in denominators. And so we do this thing called rationalize the denominator. So you need to rationalize your denominators. And so what that means is no denominators in radicals and no radicals in denominators. So to help us with this, we are going to take a look at the practice problems. So if you would please grab your book and open up to page 694. 694. So A, and I'm going to do these double big just so it's really nice and obvious what I'm doing, very readable. So for A, we have the root of 5 over 3, the square root of 5 over 3. And so the quotient property will tell us that this is really square root of 5 over the square root of 3. But again, we want to rationalize that denominator. So square root of -3 is an irrational number. I want to make it a rational number. Well, what I can do here is I can multiply by a form of 1 where I use the square root of 3. Because then the square root of 3 times the square root of 3 will just be 3. And up top, the square root of 5 times the square root of 3 becomes the square root of 15. And that, ladies and gentlemen, is my simplified answer. So for B, I have the square root of 11 over x. Now the directions told us to assume that all variables are non-negative numbers. So as long as it's non-negative and not 0, we're okay here. So if that was a negative, we'd have no real solution. So ladies and gentlemen, this then would be the square root of 11 over the square root of x. So if you want to cancel out a square root, just multiply by it. Because of course something times itself is that thing squared, and the square would cancel out your square root. So square root of x times square root of x is just x. And up top, a square root of 11 times square root of x will be the square root of 11x. Moving on to C. I have the square root of 6x to the 6th power. Oh, sorry. They already split the radical for you. Over the square root of 27x. So first things first, before I actually go and try to rationalize the denominator, let's just start by simplifying our radicals first. So up top, there's no perfect square that I can pull out of 6, so I'm still going to have a square root of 6 in there. But the square root of x to the 6th power, remember that when you have a root of a power, that you can basically divide the exponent by the index. So 6 divided by 2 would be 3, so I have an x cubed that will come out of that. In the bottom, I do have 9 that would go into 27, so the square root of 9 is 3, but that will leave behind another 3 and an x. Because square root of 9 times square root of 3 would give me square root of 27. So by simplifying it, we can see that really what I need here is just a square root of 3x over a square root of 3x. And so when I do that, I'm going to get an x cubed and then a square root of 18x over, and then down here I'm going to get 3 times 3x. So if we simplify a little bit further, so first of all I'm going to notice, boom, I can reduce that to an x squared and that will disappear. Up top now I've got a 9 that I can pull out of that, so square root of 9 would give me a 3, and then I'd still have an x squared, and then I'd still have a, oops, not just x, because square root of 9 times 2 would give me 18. So square root of 2x is there. On bottom, I'd have 3 times 3 is 9. And then, of course, 3 and 9 reduce to 1 and 3. So this would be an x squared times 2 square root of 2x over 3. Now, ladies and gentlemen, I can further simplify this. We're going to do it one more time. And we're going to use the quotient property of radicals backwards this time. So instead of splitting this into two radicals, we're going to combine it as one big radical. And so by doing this, this will allow me to reduce my fraction first. So I can reduce my x and my x, so that'll be x to the 5th now. That'll be gone. And then I've got a 3 that goes into both of those. That would be 9. And up here, I'd have a 2 left over. And so now, if I split this, this will be the square root of 2x to the 5th. And on bottom, the square root of 9. Well, that works out nicely for me because square root of 9 is a rational number. And up top, 2 is going to be stuck. But if we take 5 divided by the invisible 2 here, then that means I'm going to have an x squared left over because 2 goes into 5 2 times, but with 1 left over. So there'll be 1x left in the radical. And I get the same answer. So that is another option for letter C. Letter D brings in a new challenge. And so I'm going to take a look at my dry erase board here for just a second. If we go back to letter A real quick, what we really did here was we split this up like so. So the result that we actually got here was the square root of 5 times 3, which is why we had a 15. And on bottom, we had the square root of 3 squared. And it's because we had 3 times 3, which is 3 squared, that this just becomes a plain old 3, no radical. Whereas on top, again, I get that 15. Now we skipped that step, but that's where this came from. We created a square that canceled out the square root. So if I take a look at D, if I end up taking the square root of 5 minus 6, and I multiply that by the square root of 5, if I take 5 minus the square root of 6, there we go, and we multiply that 5 times the square root of 6, minus the square root of 6. So essentially what we're doing here is we're squaring it. Will that cancel out the square root? Well, remember that when you have a plus b squared, this gives us a squared plus 2ab plus b squared. So applied to this situation would give me 5 squared, which is 25, plus double the product. So the product would be 5 square roots of 6, doubled would be 10 square roots of 6, and then finally b squared, so that would be a negative square root of 6 squared, which would just be 6. So is this going to be rational? No, because that's square root of 6. So it turns out when we've got something like this, when we've got basically a binomial, we can't just square the denominator. That's not going to work for us. On the other hand, we've learned a special property about binomials, that if instead we multiply conjugates, then the result is a difference of squares. So applied to this situation here, we would get 5 squared, which is 25, minus the square root of 6 squared, which would just be 6. Which of course, 25 minus 6 is 19, which is a rational number. So ladies and gentlemen, when you run into a situation like this, in order to rationalize the denominator, we will have to multiply by the conjugate in our form of 1. So 5 plus the square root of 6. So now down here, we know that this will become a difference of squares, so it'll be 25 minus 6. Up top, the 3 will distribute to the entire quantity. So 3 times 5 is 15, plus 3 square roots of 6. Finish it off, 15 plus 3 square roots of 6, all over, and 25 minus 6 again is 19. And that is my simplified answer. So, letter E, 3 over the square root of 7 minus 1. So same idea here. In order to get rid of that square in the square root of 7 minus 1, we're going to multiply by 4 over 1 using the conjugate. So on the bottom, I'm going to get a difference of squares. So square root of 7 squared is 7, minus 1 squared is 1. Up top, I'm going to go ahead and get 3 times the square root of 7 plus 3 times 1, which is just 3. So simplify that further. 3 squared is 7 plus 3, and 7 minus 1 is 6. But notice that each one of these terms can be reduced by 3. So remember that reducing needs to distribute to every term. So if I divide that by 3, I get a square root of 7. Divide that by 3, I get a plus 1. Divide that by 3, I get a 2. So there's my final answer. And that, ladies and gentlemen, is our lesson.